How do you keep winning at Mario Kart, man? It's just maths.
Let's say we represent the car as a point on the velocity time graph. Over a period of time, it will form a curve. This curve can be represented by an equation. To calculate the distance that each cart has traveled, we need to use integration to find the area under the graph. Inversely, to find the acceleration of the carts, we need to differentiate the curve to find the gradient. To find out which cart is faster, we need to calculate which one travels the furthest distance in the same period of time.
In order to find the displacement of the cart, we must integrate the velocity function of the cart with respect to time. Here, we can see that the velocity of the first cart is the entire root of 30t. This can be written as 30t the whole to the power of 1 by 2. When the velocity is integrated with respect to time, we get the integral of 30 to the power 1 by 2 into t to the power 1 by 2 dt. This is given by simply expanding the bracket, and the dt represents the variable with respect to what we are integrating, where t stands for time. 30 to the power 1 by 2 is a constant and hence can be taken out of the integral, leaving 30 to the power 1 by 2 into the integral of t to the power 1 by 2 dt. Now, using the laws of integration, we know that t to the power 1 by 2 when integrated simply results in t to the power 3 by 2 divided by 3 by 2, or 2 upon 3 into t to the power 3 by 2. Hence the integral would be 30 to the power 1 by 2 into 2 divided by 3 into t to the power 3 by 2. When this is multiplied, we get 2 root 10 divided by root 3 into t to the power 3 by 2 as the integral of velocity, or the displacement time function. We follow the same process for the second equation. Here, the velocity of the cart is 15 into the cube root of t, or 15 into t to the power of 1 by 3. When the velocity is integrated with respect to time, you get the integral of 15 into t to the power 1 by 3 dt. Here again, dt stands for time, indicating that the equation is being integrated with respect to time. 15 being the constant is taken out of the integral. Hence, the integral of v is equal to 15 into the integral of t to the power 1 by 3 dt. Using the laws of integration, we know that the integral of t to the power 1 by 3 dt is simply 3 by 4 t to the power of 4 by 3. This, when multiplied with the 15 in the equation, will yield the integral of the velocity to be equal to 45 divided by 4 multiplied by t to the power 4 by 3. This equation is the integral of the velocity of the car, and it is also known as the displacement time function of the car, as it shows the displacement of the cart at each unit of time.
Now I understand the math behind Mario Kart.
Thank you so much for playing my game. Bye, everybody.